plus 2. If Leon is 5, how old is Maria? She's 2 years older than Leon. Maria's age is equal to Leon's age plus 2. If Leon is 5, we can write Maria's age as 5 plus 2. If Leon is 50, we can write Maria's age as 50 plus 2. Let L be Leon's age. Then we can write Maria's age like this, L plus 2. L is a symbol that represents a value, in this case, Leon's age. Every year, Leon becomes older, and the value represented by L changes. But Maria is always L plus 2 years old. When we use letters to represent numbers, we open the door to a new part of mathematics, algebra. Algebra helps us to generalize, to find patterns, and to express connections. If you write Maria's age as L plus 2, you have an algebraic expression. L plus 2 is more general than the numerical expression 5 plus 2. Here's another algebraic expression that you will surely recognize. The base times the height. It's what you do to calculate the area of a rectangle. The algebraic expression b times h applies to all rectangles, not just this one. To calculate the expression's value, we plug in the numerical values for the base and height and get 12 times 4, which equals 48. Shall we take another example? Okay, Leon wants a new bicycle, and his father is going to help him. If Leon earns enough money for half the bike's price, his father will pay the other half. Write an algebraic expression that describes how much money Leon needs to save if the bicycle he wants costs C kroner. Leon needs to save C divided by 2 kroner. Yes, keep peeling those potatoes a while longer. Algebra is a way of expanding a mathematical argument from concrete numerical calculations with numbers onto something more general. When you write an algebraic expression, you let one or more numbers be represented by a symbol.
And as simple as possible. Here's an algebraic expression with 3 terms, 4x plus 2 times x minus x. The first thing you can do when you see something like this is to get rid of that multiplication sign between 2 and x. The number that stands in front of a variable tells you how many of that variable you have. We call this number the coefficient of the variable. There's no need for a multiplication sign between the coefficient and the variable. In this example, all the 3 terms have the same variable. They're all of the same kind. That means we can go ahead and add them together. 4x plus 2x is 6x. But then what? The third x term doesn't have a coefficient. It's just an x. If there's no coefficient spelled out, it means there's one of that variable. X means 1x. So you subtract that last x and get a total of 5x. And there you go. We have simplified the expression to 5x. Here's another algebraic expression. This one has 4 terms. 4y plus 5 minus 2y plus 2. Begin by bringing together terms that are of the same kind. First we gather all the y's. 4y minus 2y equals 2y. Then we sum up the constants separately. The constants are the numbers that don't have any variables at all. 5 plus 2 equals 7. We say that we've combined like terms. That means we've brought together all terms that are of the same kind, apples with apples and pears with pears. The algebraic expression we have left has 2 different types of term, one y term and one constant. Let's do another one. 2m plus m squared minus 5. Are there any like terms here? No, there isn't. M and m squared are not the same kind of term, so we can't add them together. Just like you can't add together the distance 2 meters with the area 1 square meter, you can't add m and m squared. They are different units, different kinds of term, so in this expression all the like terms are already gathered. But there is one thing we can do. It helps to sort the terms, putting the one with the largest exponent first. So we rearrange it like this. First the m squared term, then the m term, then the constant at the end. This doesn't change the value of the expression at all, but if you always sort expressions like this, you make them easier to read and interpret. An expression like this with several types of term is called a polynomial. Poly means many. Now we're going to do some multiplication as well. Let's start simply. X times 5. We write that as 5x. If there's no sign in between, remember, that means multiplication. Okay, what about this one? 3x times 4. Well, it means just the same as 3 times x times 4. And when we're doing multiplication, the order of the factors doesn't matter. So you might as well write it like this. 3 times 4 is 12. And remember, no need to write the multiplication sign between the coefficient and the variable, so it's just 12x. Look at the first and the last row. Normally you'll do all of this at once. 3x times 4 equals 12x. What about this multiplication then? Now we have an x in both factors. Let's write in all the multiplication signs just to make it clear. Then we can place all the x's together at the end and start from the left. Well, 3 times 2 equals 6, but what's x times x? It's x squared. 3x times 2x equals 6x squared. If you think of x here as a distance, say a meter, then 3x times 2x is a rectangle with an area of 6 meters squared. Meter times meter equals meters squared, just like x times x equals x squared. Again, you're not going to write all of this into each calculation. When you understand what's happening, you just go from the first to the last row here in one go. Here you need to watch out. Note that there's a plus sign in the middle of this expression. So here we must follow the order of operations, which tells us that multiplication comes before addition. So we do the two multiplications first. 4 times 5x is 20x, and 3 times 2x is 6x. Now we have two terms of the same kind, so we add those together, and that equals 26x. Okay, that's multiplying with one variable. Let's bring in another one. Here we are asked to multiply x by y. It's really simple. X times y is xy. Remember, if there's no sign written in between, it means multiplication. What about this then? 2x times 3y. Well, 2 times 3 is 6, and x times y is xy. And we miss out the multiplication signs. 2x times 3y equals 6xy. One last example. Here we combine what we've learned so far. First, multiply the coefficients. 5 times 2 equals 10, then multiply the variables. Y times x is yx, but we write it as xy to keep the expression in alphabetical order, and xy times y is xy squared. Note that it's only the y that is being squared here, and drop the multiplication sign. Negative numbers, and how to multiply them. Have you got a grip on parentheses? Good. Then let's multiply with negative numbers inside parentheses. Here's a parenthesis, and here's a negative number in front of the parenthesis. We don't even have to spell out the multiplication sign. If there's no operation stated, then it's multiplication. When we multiply with a parenthesis, we multiply with each of the terms, one by one. Tag along. Minus 3 times x equals minus 3x. Minus 3 times 2 is minus 6. Done. Now let's make it a bit more challenging and choose an expression with a minus sign inside the parenthesis too. Minus 4 times y minus 6. We do as always, multiply what's in front of the parenthesis with each of the terms inside it. Minus 4 times y is minus 4y. Minus 4 times minus 6 is, do you remember? Multiplying two negative numbers with each other is like removing debt. It's something positive. Minus times minus is plus. So minus 4 times minus 6 is positive 24. Are you still following? If not, then go back and review how to multiply with negative numbers. Here's one that might look a bit odd. Minus, parenthesis, z plus 3. What's this? Isn't there supposed to be a number in front of the parenthesis? Well, there is a number in front of the parentheses, but you can't see it. A single minus sign in front of a parenthesis you can read as minus 1, like this. That's easier, right? Minus 1 times z is minus z. Minus 1 times 3 is minus 3. Look at the equation. Compare what's on the left-hand side to what's on the right. There was barely any calculation involved. Multiplying with minus 1 is the same thing as changing sign. Let's test this rule in another calculation. Minus parenthesis x minus 9. Multiplying with minus 1 is the same thing as changing sign, so let's change signs. X with opposite sign is minus x. Minus 9 with opposite sign is plus 9. Done. It doesn't matter how many terms there are in the parentheses. Look here. A minus sign in front of a really long parenthesis. Minus, parenthesis, x minus y plus z minus 3. Let's change signs. X with opposite sign is minus x, minus y with opposite sign is plus y, plus z with opposite sign is minus z, minus 3 with opposite sign is plus 3. And there's the answer. When you see a lone minus sign in front of a parenthesis, you can remove it if you change the signs of each of the terms in